Alright, so let's talk periodic table. Why is the periodic table important? The periodic table is one of the most useful tools to you guys because it organizes a lot of information about the elements that we know about. So let's talk about how the periodic table is organized. Okay, the current periodic table is organized by increasing atomic number. And it's very important that you guys know that. Okay, it's the increasing atomic number. On the periodic table, you have horizontal rows, which are called periods, and you have 7 of those. Then you have vertical columns that are called groups, and those are labeled from 1 to 18. Okay, so if you guys look at this periodic table here, these are your periods that go horizontally. Okay, you've got 1, 2, 3, 4, 5, 6, and 7. Then you have your groups, which are your columns. Okay, and here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. One of the interesting things about the groups and the rows is that elements in the same group, okay, remember those are the columns, are going to have similar chemical and physical properties. And the reason that is because they're going to have the same number of valence electrons. If you don't know what valence electrons are, you can either go Google it now, or we will talk about it when we talk about atomic models. Okay, elements in the same period have the same number of electron shells. Again, if you don't know what electron shells are, you can Google it, or we'll talk about it when we talk about atomic models. Alright, so let's take a closer look at one of the actual boxes in the periodic table. You guys will have to know how to read one of these. So let's look at one and talk about it. I want you guys to copy this picture to the right, and I want you to write down all of this information that you see right here. Also, to atomic number, you're going to add this that's in red. Okay, your atomic number is the number of protons in an atom's nucleus. It's usually the number found at the top of the box. Okay, and no two elements have the same atomic number. The reason that is because atoms are defined by the number of protons that they have. So germanium will always have an atomic number of 32. It will always have 32 protons. Other elements will have different numbers of protons, but not the same as one another. Your chemical symbol is just a shorthand way of writing that name so that when you're writing chemical equations, you don't always have to write out germanium. You can just write Ge, and anybody that reads that will know you're talking about germanium. Okay, the other part of your periodic table cell is the mass number. It's often found near the bottom of the cell. And in general, we consider it to represent the number of protons plus neutrons in the nucleus. It's actually calculated using the number of isotopes of the element, but you guys don't have to know that. For now, I just want you to consider it the number of protons plus the number of neutrons in an atom. You guys know how much I love units. Okay, the unit of measurement for an atom we call AMUs. That stands for atomic mass unit. So when you're looking at this right here, okay, this is measured in AMUs. That's your unit for this. Alright, finally, let's talk about how elements can be grouped on the periodic table. In this PowerPoint presentation, we're just going to talk about metals, nonmetals, and metalloids. When you guys get to class next time, we're actually going to talk about the periodic table families. Okay, but right now I want you guys just to focus on metals, nonmetals, and metalloids. So if you're looking at a periodic table, which we will actually color one tomorrow like this, it'll be divided into 3 main categories. You have your metals, nonmetals, and metalloids. If you're looking here at this periodic table, your nonmetals are that light green color. Your metals is where you see the blue, and your metalloids will be found where the purple is. Okay, your metals, again right here, the blue. Oops, sorry. Your metals are good conductors of heat and electricity. They often tend to be shiny, They're ductile, which means they can be stretched into thin wires. You guys probably remember seeing this word on your physical properties list. They're also malleable, which means they can be pounded into thin sheets. And the way I remember that is malleable sounds like mallet, and you use a mallet to pound things out. Okay, so those are properties of metals. Your nonmetals tend to be sort of opposite of your metals. They're poor conductors of heat and electricity. They're not ductile or malleable. They're often brittle and they break easily. And actually quite a few of them are gases, so those don't break easily unless they're solids. And they tend to be dull. They don't tend to be shiny like the metals. Remember the in-between? You guys had those metalloids where the purple is? Okay, and since they sit right in between the metals and the nonmetals, they tend to have properties of both. Okay, they are solids most often, and they can be shiny or they can be dull. They can conduct heat and electricity better than nonmetals, but not as well as metals. They're also ductile and malleable, but not quite as much as the metals are. Alright, so looking back at your PowerPoint, I want you guys to remember the periodic table is a way of organizing elements. Okay, it's arranged by groups and periods. Remember that groups have those similar physical and chemical properties, whereas periods have similar electron shells. When you're looking at those boxes, the atomic number, which is usually near the top, is the number of protons, and each element has its own unique atomic number. None of them share the same atomic number. Okay, the atomic mass, or also known as the mass number sometimes, is equal to the number of protons plus the number of neutrons in an atom. Your mass unit for an atom is an AMU, which stands for atomic mass unit. And I also want you guys to remember that the periodic table can be categorized into metals, nonmetals, and metalloids, and each of those can be identified by their properties. Okay, and I also want you guys to remember some of those properties looking back over your notes. Alright, that's everything, guys. I hope you guys have a great afternoon, a great night, great day tomorrow, and I will see you in class next time.